Think about your immune system for a second. The first thing that probably comes to mind is that it provides protective resources against harmful agents or pathogens that could possibly enter your body. What if one day those immune cells mistook you for the harmful agent and started attacking the healthy cells or components circulating your body? That is exactly what happens during autoimmune disorders, and that is exactly what we are going to be elaborating on today, specifically an autoimmune disorder called multiple sclerosis, or MS. In today's video, we are going to be discussing what is multiple sclerosis. We're going to talk about the central nervous system and its role in MS. We're going to go in depth on myelin sheaths, demyelination, and remyelination. We're going to cover the types of MS, the cognitive, motor, and sensory effects and impacts that MS has long and short term, and the strides and research efforts being made to help MS diagnoses. Multiple sclerosis is technically considered an autoimmune disorder. It is basically where the neurons in your brain and spinal cord contain a myelin sheath that insulates the axon of the neuron that transmits the electrical signal to the rest of your body. That is being broken down because of your immune cells attacking it, therefore making it difficult for those signals to be transmitted throughout your body, causing different motor, sensory, and cognitive impairments. Your central nervous system, or your CNS, is made up of your brain and spinal cord. These two areas contain something called a neuron. Here is a depiction of a healthy neuron within your brain or spinal cord. It is made up of multiple components such as a soma or cell body, dendrites, a nucleus, an axon, which is basically a tunnel, lack of a better word, that the information or electrical signal is sent down in order to get to the synaptic vesicles or the axon terminals that synapse onto other neurons throughout your body in order to interpret the signal that it's trying to send. There are multiple myelin sheaths which basically insulate the axon to create a stronger signal so that your body can interpret what it needs to do. There is an oligodendrocyte, which is basically a glial cell within the CNS that is able to attach itself onto multiple myelin sheaths, also strengthening the signal or information that needs to be interpreted. When all of these components of a healthy neuron are working the way that they are supposed to, they function to control motor abilities such as muscle movement, balance, and coordination, sensory abilities such as touch or olfactory sensations, and cognitive abilities as well, such as vision and decision making. The main immune system dysfunction that occurs in MS is because normally the blood-brain barrier is what keeps the immune cells from entering your central nervous system. Usually post-infection, the blood-brain barrier becomes more permeable, allowing cells of the immune system, such as T lymphocytes or T cells, which are white blood cells, to cross the blood-brain barrier, ultimately mistaking the myelin sheaths as a foreign pathogen. The mechanism of attack of the T cells after crossing the blood-brain barrier can be depicted here on a neuron. As you can see, the myelin sheaths on the axon are being broken down, therefore the electrical signals are no longer as strong. When the breakdown occurs, the oligodendrocytes that are attached to the myelin sheaths begin a process called remyelination, which is where they try and rebuild the myelin sheaths, but it is not fully effective, therefore leaving behind scar tissue, hence the term sclerosis. After the damage of demyelination from the T cells, as well as the initiation of remyelination creating scar tissue, unfortunately, the nerve signals have long-lasting disruptions and can no longer communicate effectively with the rest of the body. The slowing or blocking altogether of the neuron signal transmissions due to demyelination can be a very chronic issue. This creates negative effects like we had talked about prior in the motor and sensory capabilities of your brain. These are both located in the frontal lobe of your brain, which contains the somatomotor cortex, and the parietal lobe of your brain, which contains the somatosensory cortex. As the oligodendrocytes initiate remyelination, as the demyelination process has damaged each myelin sheath, sometimes it is not quick enough, therefore leaving the axon of the neuron exposed, which is very dangerous because the axons can actually be damaged as well, creating permanent damage. Trying to detect a form of multiple sclerosis through the process of demyelination within a person is actually very difficult to do. Usually it can be detected through MRI scans, and most begin as a CIS, which is a clinically isolated syndrome, which is technically not a diagnosis of multiple sclerosis. During these initial MRI scans, a lot of the time, things called lesions or plaques, which are little white spots, as you can see in this photo here, are detected and are usually in the white matter of the brain, however, have been found more recently in the gray matter as well. A lot of the time, they are located on the optic nerve, the spinal cord, and the brainstem as well. These lesions or plaques can cause or strengthen the initial impairments that are being caused by MS, such as vision problems or mobility issues. A lot of the time, MRI scans can detect these lesions, which can help determine an actual multiple sclerosis diagnosis. There are 4 types of multiple sclerosis or different stages that occur. The first stage that occurs after clinically isolated syndrome has been detected is relapsing remitting multiple sclerosis, or RRMS. Depicted by this graph here, it is when unpredictable relapses of symptoms occur with long periods of no change or no new disease activity detected. A lot of the time, there are recovery cycles during this form of MS, and there are temporary repairs of the myelin. The next stage can be depicted by this graph here. It is primary progressive multiple sclerosis, or PPMS, which is where there is continuous progression of nerve damage with no recovery, and there are little to no relapse periods, unlike RRMS. The next stage after PPMS is a stage called secondary progressive MS, or SPMS, which can be depicted by this graph here. It is similar or a mixture of both RRMS and PPMS because it begins with periods of relapses of symptoms, but over time you can see the continuous progression of the disease where there should have been a relapse period. This is usually the stage where axonal damage increases, leading to worsening and worsening conditions. The last stage we are going to talk about is called progressive relapsing multiple sclerosis, or PRMS, which can be depicted in this graph here. As you can see, the effects and the disabilities of MS are much higher than any other stage of multiple sclerosis. However, relapses do occur, but during the relapse phase, they are progressing at an increasing rate, which creates a more rapid progression of disability over a shorter period of time. This usually leads to more serious neurological damage. The long-term effects and impairments that come from multiple sclerosis can be different for every person and every stage. Some of the symptoms that I'd like to mention can be identified as motor impacts lead to symptoms such as tremors or muscle spasticity. Sensory impacts lead to symptoms such as numbness, tingling, or random pains. And cognitive impacts can lead to symptoms such as impaired memory, attention span, or decision making. Currently, there is no cure that exists for people that are diagnosed with any stage of multiple sclerosis. However, the aim of professionals and researchers at the moment is to reduce the disability burden. To conclude this video, I would just like to emphasize the seriousness of this condition and the empathy that we must have for our friends and family that are being affected by it. Remyelination strategies and neuroprotective therapy has done wonders for those that have been diagnosed. I encourage all of the viewers of this video to practice healthy habits so we can all live healthy and happy lives. Thank you.